I put up a quote here to start with from the NASA Science Mission Directorate, talking about, and we've talked about this in the last couple of talks that I've done with Europa Clipper and Ocean Worlds, and how pretty much everything, all of our space exploration is geared in some way as to trying to figure out if there is life out there beyond Earth. So that's um, one of our most important questions that we're trying to answer as humans, because we're explorers by nature, going all the way back to exploring the world around us, setting off across oceans and exploring new continents and all that. So we're explorers by nature. So that's one reason to go, but also to answer these big questions. Not letting me advance, sorry. Okay. All right. And just for the new folks, the long-term members know I kind of put this up here. So as Todd mentioned, I'm part of the group of what is called Solar System Ambassadors. So that's a group of probably 800 to 1,000 people. We're volunteers for NASA, and we put together programs like this and take them out into the communities to kind of share the some of the science and discoveries that NASA is doing. So just here's a little bit about the program, but keep in mind that I am a volunteer. I'm not a rocket scientist, so I, hard questions I may not be able to answer. One other thing is, there's a lot of questions about budgets and missions and all that, and I really can't speak to any of that because I'm not a spokesman. So if those come up, I'm not going to be able to speak to that. So, okay, next question, Ari. And so here, this is just what I put together as a mission update. I think we have 7 missions in here. Some of them will spend a little bit more time on. Some, several are just a single slide. But kind of went back to some of the older missions that we haven't heard of, because they haven't made the news. But there's a lot of good science going on in the background. Go ahead, next slide, please. Sound check, sound check. Okay, sound works. Okay, so we're going to start with Mars Perseverance, exploring in Jezero Crater. So if any of you heard the last week or two, there's been news out that they have discovered. They're still calling it a potential biosignature, but the reason it made the news is it went through all the checks, and the only way we're going to be able to confirm it is to bring that sample back to Earth. But the important thing about this particular sample is they ruled out everything else. Any kind of mechanical or chemical process that have created these formations and these chemical compositions, they've ruled out everything. So the only thing left is that it is probably a genuine biosignature. So the rover landed up in the crater, and it's over the last couple of years, it's worked its way up onto the crater rim. So this is an image that's about a week old. It's called Sorolla Ridge, and this is up on the crater rim, and this is just a picture the rover took. So this was kind of just to give you an idea of the terrain that it's exploring right now. Next, Ari, please. So I put these 2 images back in that we've used before, and these are images from orbit of Jezero Crater. The one on the right there shows the landing site with the star. So, and then on the left, you can see that detailed map with that river coming in and going through the crater wall, and then that delta right there. So that's all sedimentary rock. So where it initially landed, where that star exploring the crater floor, they found a lot of igneous rock and all that would have resulted from the original volcanism when Mars had a molten interior. And of course, working up on that river delta, they found a lot of sedimentary rocks. Click go, Hari. There's a couple of sequences here. So that spot right there is, we're going to zoom into that, but that's the area that the sample, this particular sample, was found. So that is the riverbed, Narita Vallis, and then that area immediately above and below it, that's called the margin, and that's kind of the transition point between the crater wall and the crater floor. And we're gonna zoom in. I'm gonna show you exactly where they were looking and the type of formations they were looking for. So go ahead, Hari. So here's the detail. Now you see the dashed line is the path that the rover has taken since landing over there in the Sita Formation. So they worked their way along the crater floor, up along the delta, and then over here into the riverbed. So this inset is where the rover was exploring last summer. So the sample, which is called Sapphire Canyon, was taken, I think, July 21st last summer. So it's taken them about a year to analyze it, and then they had a team go through it to discover all this. Click next. So now we've got it zoomed in here, going across the riverbed, and then you can see crossing that formation that they call Bright Angel, and then the Sapphire Canyon is taken right up against that margin formation where it's coming down into the riverbed. Next. And we're going to keep working our way down. So here's a satellite shot from orbit. So if you kind of look at the path the rover takes and look at the areas they explore, they're always going up for these outcrops, and they're looking for places where sedimentary rock might be exposed, and these are the places we're just not going out across flat terrain and just digging a hole at random. We're going up and looking for interesting formations and trying to take a sample there to try to get the most scientific value. So, but you can kind of see where they went up into that area where Bright Angel is at the top and up against that outcrop. Next. We'll zoom in a little bit more. And Sapphire Canyon was taken right there where that margin transitions to the crater floor there at Bright Angel. Next. And so here's some shots from the rover from the ground. So looking, the top image there, you're looking back into the riverbed, and you can see all, that's definitely sedimentary rock, and you can see those ridges there. We're kind of looking back towards where the river comes in. We're not looking towards the crater. The bottom one, we're looking at that Bright Angel, which is similar rock, even though the coloring's different. And but this is where, just off the top of that picture, is where you're transitioning to that vertical crater wall. Next. And so here is the interesting rock, which is called Chayava Falls. Next. And so this is the rock that gained the team's attention. And if we go ahead and go next here, it's called Chayava Falls, but you see those little gray-green inclusions there. This is mudstone. And what they determined, or what it looked like, is these little, what they call leopard spots, are formations with a dark ring around them. So what this ends up being is those are minerals that are likely the result of organic materials in those spots interacting with the matrix they're in. So if you can imagine some kind of organism in that mudstone, and then we've seen some of the similar formations here on Earth where that life form is, and then there's a transition point of these chemicals that are forming right there. So they thought this was a good spot to take a sample. Next. So here's just a spot of what the core drill looks like. And then I've got one of the sample tubes, and you've got a picture of the sample tube. So the rover, when it landed, it took 43 of these sample tubes with it in a carriage on board. Had 43 sample tubes for rock samples, and then it also had an additional 5 what they call witness tubes. So every so often, where they take an interesting sample, they'll open one of those witness tubes and just open it and take an atmospheric sample, and they will leave that. So occasionally this is sample number 25. I think they've actually taken up to 29 by now. And every so often they are caching these samples on the surface in an area that's pretty close to each other. So with the intent, if we do a sample return mission sometime in the future, that there will be several of these sample tubes, and then whatever vehicle we end up as a lander or to go retrieve these samples, they're not going to have to trek the whole distance of the rover's path to pick these up. The rover's putting these into a certain area. So that gives you an idea what the sample tube looks like. So then the rover also takes a sample and analyzes it. So it's basically a rolling astrobiology lab, and it's got mass spectrometers and gas chromatographs and all these instruments on board that are designed to look for signs of past life. So the analyzers can analyze these samples for the minerals. So they find stuff like silicon dioxide and ferric oxide and all of these basically organic materials. And by looking at those, I think they also use it. I think it's also got an X-ray fluorescence spectrometer on here. So by putting all that together and making a determination of how many of these minerals are and what their composition are, they made the determination that basically nothing else could have created this other than a biologic process. So it's very complicated, very long and complicated paper as to how they got to this solution, but it's a pretty interesting read. So, but that's kind of the short story. So I think that is it for Mars. And unless we have any questions, we'll move on to Juno. So Juno was launched back in 2011. So I do have New Frontiers is one of the programs that is very interesting. These are kind of medium. They're not like Europa Clipper or one of the rovers. These are medium class missions, but they're high science returns. So and there's 4 right now. New Horizons that flew past Pluto was 1. Jupiter was New Horizons 2. OSIRIS-REx, and the 4th one that we briefly talked about is Dragonfly, which will go to Titan. So Jupiter launched back in 2011 and entered Jupiter orbit in 2016. So it was designed to measure primarily Jupiter's gravitational and magnetic field and map all of that out. So it had a 5-year primary mission, which ended in 2021. And so they've done an extended mission, which will keep the data coming in through the end of this month. But spacecraft like this, it's been exposed to Jupiter's radiation for quite a bit, and there is fuel on board. So I did take a brief look. I haven't seen anything where they had put together a request for any further mission extension. So this mission may come to an end this month. But interesting thing they did is from starting in about 2022, they started taking closer looks at Io, and they found some really enormous volcanic activity. That one up in the upper right, that's the southern hemisphere, so that's a hot spot. And then if you look at these images here that go through 8 or 9 months, and there in December you can see that huge volcanic plume coming up from that area. So measured some of the largest volcanic activity that we've seen on Io. So a little bit extra science out of an extended mission. So okay, next. So we're going to hit Europa Clipper real quick, even though we've done it. So it's on its way to Europa. It will go into Jupiter orbit, and right now it's out. It did a gravity assist at Mars back on March 1st. It's going to go out and come back, and what you're seeing right there, do another gravity assist at Earth next December 26th, and then that will slingshot it all the way out to Jupiter, and it will go into Jupiter orbit in 2030, April 2030. So the idea there is to put it in a very elliptical orbit around Jupiter and do close flybys of Io, and that will keep the spacecraft out of the strongest part of Jupiter's radiation belts for the most of the time, to try to these instruments they're sealed up in a titanium vault, but the radiation at Jupiter is very intense, so it's very hard on spacecraft. Next. All right, Osiris-Rex. Some of y'all know one of my favorites. This was launched in September of 2016. Made a couple of year trip out to an asteroid called Bennu, and spent a couple of years out there surveying the asteroid, making detailed maps. And then in 2020, actually took a sample from the surface of the asteroid. So that lower left image there, you can see that's the sample container that this thing was on an arm, and they very gently they extended this on an arm at a perpendicular angle to the asteroid, and they very gently bumped it into the asteroid. And at the same time, they had canisters of pure nitrogen on that arm, and they discharged those canisters and blew this material up into this collector and gathered all of this. So there on the right side, you can see what some of the material looks like. Up there, the upper left, that's the sample return container. So those are actually here in Houston at JPL. They built a new annex onto the building. I think it's building 31 where the moon rocks are stored. And they built a brand new annex just for this sample. So this is most of this is here being analyzed right now. So I think, there's a interesting bit of trivia. These two images here on the right, they did a lot of stereoscopic imaging. So this particular sample was stereoscopically imaged by Brian May, who was the lead guitar player for Queen. He's now an astrophysicist, and he worked on the project a little bit. Also worked on New Horizons. So, okay, next. Okay, so here's going to be New Frontiers 4, which will be Dragonfly, and they're building it right now, doing the design and engineering, and this one should launch in October of 28 and arrive at Titan in 2034. So this will be a lander. It's about the size of a small car, but it'll be an 8-bladed rotorcraft, and it will design to land on Titan and basically fly around the surface. I think they're talking, maybe as many as 50 sites over a couple of years, and analyze the environment. Hit next, Hari. I think I've got the mission objectives here. Yeah, so we're going to look at chemistry. A lot of hydrocarbons on Titan, a lot of methane. So they want to look at the current chemistry and see if there's any prebiotic processes that may have occurred or may be occurring now, and how far that's gone. So that is, would be a big indicator of possibly how life occurred here on Earth early on. And then there are instruments on there to see if possibly there may be some habitability by either water-based or hydrocarbon or methane-based life, and then also search for biosignatures, similar to what Perseverance is doing.
Hi, Leonard. This is Todd. I have a question for you. Okay, so we're talking about water-based or hydrocarbon-based life. Do you have any insights into what might be sort of the analogous molecules or such that to water-based life that a hydrocarbon-based life would use?
Yeah, I think the main thing they're looking at is methane.
Okay.
Which is one of my, one of the things I think about is what, if what we know here is life on Earth. So were we to go out there, would we even recognize hydrocarbon-based life? So that's a big question, for me. I'm sure that the folks designing this have taken that into account, but it's an interesting question. Does that answer you? Answer your question, Todd?
It did. I unfortunately put myself on mute, and so I was saying, it would be really interesting to understand, what the analogs are from a water-based life form to a hydrocarbon-based life form. I guess I'll do some research in the science fiction literature and see what the science fiction authors might say.
All right, next story.
Thank you. Yes.
And then some of these are in the ocean worlds, but just if you hadn't seen that, so these are that middle image is Titan from the Cassini mission, and you can see how much all of that dark area is liquid. It's lakes, so it's liquid methane. And then I've just got one in the upper left there. That's one of the that's called Legia Mare. That's one of the largest lakes. It's up on the northern, close to the North Pole of Titan, and that's a huge lake. And you have basically the same thing as a water cycle on Titan. We have water, rain going to the oceans and rivers. They have all the same processes are occurring on Titan, except with liquid methane at 200 degrees below zero. All these boulders here on the right, that's all water ice. And then of course you've got that orange coming from the methane atmosphere. But yeah, you've got methane rain, methane rivers, methane lakes, just like here on Earth, except with methane. So it's a very interesting, very interesting system. There's a lot if you consider methane versus water. There are a lot of comparisons between Titan and Earth. Next. Okay, and then we're gonna talk about New Horizons in a long time, and there's still a lot going on. So this was New Frontiers 1, launched back in January of 2006, and went all the way out to Pluto. Took it 9.5 years to get there, and we've seen those gorgeous images from Pluto. And then we did flyby of what's now called Arrokoth, that was on New Year's Day of 2019, and now New Horizons is out there another little over 62 AU from the sun. So that's about 5.5 billion miles. And down there at the bottom, you can see light travel time is over 17 hours round trip. So it's way out there, and it's still doing a lot of science. They've found like I think 250 additional Kuiper Belt objects, and they're doing one thing they've run into is out there. So they thought, and you see that image there on the left with all the stars, that's all Kuiper Belt objects. And they had initially thought that by now New Horizons was coming to the other side of the Kuiper Belt, and they thought they were about through it. But then they had one of the new telescopes came online. Anyway, they found a new population of objects out there that extends from 60 out to like 90 astronomical units. So there are thinking they're either not really deep into the Kuiper Belt or maybe at best about halfway through. So they just put the spacecraft back into hibernation about a month ago, and it'll stay in hibernation until next summer. So they've updated software, but they've done an all-sky map of the ultraviolet, the cosmic wave background, and they're mapping the hydrogen background and all that, and they're doing this from a point. So now they're out of the inner solar system. So there's a lot of gas and dust in our inner solar system. So being way out there gives this spacecraft a lot of advantage for making these measurements, because there's a lot of it's got a clear view to a lot of this stuff. So there's some good maps coming in. And one other thing they did, I think, is on the next slide, Hari. So these images were actually taken back in 2020, but they just recently analyzed them. One of them's moving here. That's Proxima Centauri, and then Wolf 359 from Earth is the one on the right, and from New Horizons is the one on the left there. So this is a demonstration of the parallax difference between Earth, excuse me, parallax difference between Earth and where New Horizons is. And so they took these images. Now they're not navigating the spacecraft, but they took these images and they were able to almost pinpoint the spacecraft's position by using the spacecraft's view of the stars. So we're navigating from Earth. The spacecraft has a star field that we have, and they talk to it on the radio, and they navigate, commanding it from our view on Earth. But they took these images, and by using what the spacecraft could see, they could still navigate. Like I say, they're not literally navigating, but they did model it by using the spacecraft's view. So the short story is this is the first genuine example of interstellar navigation taking place by New Horizons. Next. Give it a second.
On behalf of all the men and women across our great nation who have worked to make this day possible.
Can everyone hear the video?
Say again?
They can hear the video, right?
Yes, we do.
Excellent.
I give you a go to launch Artemis 1.
For the first time in 50 years, we were breaking out of low Earth orbit to head toward the moon.
We are putting something that we dreamed about into reality.
It sent a message really to the world that we have laid the foundation for a generational rocket.
How many times in your career do you get to be a part of a first?
And liftoff of Artemis 1. We rise together back to the moon and beyond.
For Artemis, this is just the starting point.
Ladies and gentlemen, your Artemis 2 crew.
Thank you to the NASA workforce. Thank you to our industry partners, everyone in Europe that's working for this.
America has made a very deliberate choice to curate a global team, and we are going to the moon together.
We need to celebrate this moment in human history. It is the next step on the journey that gets humanity to Mars.
Am I excited? Absolutely.
We're going to test out the vehicle's ability to conduct rendezvous maneuvers, crew's ability to actually fly Orion manually, and most importantly, we're going to test the environmental control system. We got humans on board. We got to keep them safe. We got to keep them breathing. And then we're going to have them come back at that high-speed entry of 32 times the speed of sound to make sure that they can survive this for future missions.
And so we have new launch commit criteria. We have changes to our procedures, changes to our timelines.
We have new systems for crew. We have new systems in the capsule. We have an emergency egress system.
By building incrementally these capabilities, improving these capabilities that we have, we will be able to live on the moon and be able to perform science for deep space exploration.
I am ready for Artemis 2. The SLS team is ready for Artemis 2.
We are ready for Artemis 2.
We are ready.
We are ready.
All right, I'm ready. Let's go.
All right, next. All right, so Artemis 2 launching, what they're saying is no later than April next year. So next, Ari. So here is the SLS set up in the this is what they call High Bay 3 in the vehicle assembly building. So the SLS rocket is pretty much assembled and ready for flight. One thing they do need to do is install the Orion stage adapter, which I've got a picture of here. But set up here, this is what's called Block 1 configuration. We have 4 of the main engines, RS-25 main engines, same ones used on the space shuttle. 5, those solid rocket boosters are 5, again, similar to the space shuttle, but they're 5 segment now instead of 4. And so all of that together, when it lifts off, that's 8.8 million pounds of thrust, which is about 15 to 20% more than the Saturn V. So very powerful rocket. So they've got the ICPS is installed. The interim cryogenic propulsion stage is installed. You can't see it in here at the top. So what they next one, Ari. So here's the Orion stage adapter here. So these pictures are about a month old when they arrive. So what they're doing right now is the mission is going to take 4 of the CubeSats along. They're installed in this stage adapter. So right now those are being processed and installed. Once they're installed and this is ready to go, they will move this over to the vehicle assembly building. It will go at the top of the ICPS, and then Orion will mount to this, and that will complete the stack. Next. So Orion is checked out. Here it is moving from the what they call the multi-payload processing facility. They process the entire spacecraft and fuel it. And what they're doing it here in this picture is a couple weeks old. This is moving it to the launch abort system facility. So what you're seeing there, the cover is on Orion on the spacecraft itself, and then that vertical part, that's the service module. And hit the next slide, just the animation there. So here is this was just released today. This is the launch abort system with Orion below it. So that has been completed. So this is ready. The next step will be to move all of this over to the vehicle assembly building and put the whole thing together. So once that is done, then we'll probably start hearing a little bit closer about a launch date. Next. And here I just put a shot in here of Orion without the cover on it with the service module right there. So that's what it looks like. So here's your crew. So 4 crew on board. This will be a 10-day mission. This is a test flight still. They will not land on the moon. They're going to go out, and I think they're going to go about several thousand miles past it and then come back. But basically one trip around the moon and back. So next one, Hari. So here's the flight plan. They will, so like they were talking about in the video, they'll launch. They'll do a couple of orbits around Earth, and they were going to test some maneuverability about with the using some of the parts. They're going to check, docking and check manual control and all that. And then once they're ready to go there at stage 7, they'll jettison the ICPS, and then the service module will make one burn that will take them all the way out to the moon. And this mission is designed to, the path they'll take will go out and loop around the moon. That'll put them on a free return trajectory back to Earth. So this is, 10 days, but full test flight of all systems of SLS and Orion, life support, and the whole bit. So this will be if all goes well, this will be the last test flight, and then Artemis 3. I know they're already processing the rocket for Artemis 3, so I don't know if there's a projection of when it will land, but Artemis 3 is scheduled to actually land on the moon. So, all right, next. So last thing here is we talked about a little bit on Europa Clipper, but campaign is now open, and I will probably send out an email to the list, but you can go on here and go to this site and put your name in, and they will engrave your name. Actually, they're going to do it on an SD card on here. It was onto a computer chip on Europa Clipper, but they'll load your name onto an SD card, and then that will ride along with the crew on Orion, and you can send your name around the moon. Hit next, Hari. And then they'll give you get a little boarding pass. So I put a picture of mine up here, what it looks like. So I've done this on several of the Mars missions and all. It's kind of fun. So, all right, next. And that's all I've got. Sorry for the rough start.
No worries, man. The results made up for it.
Have you any questions?
That's great. Yeah, Leonard, one question I do have. So, what's your take of what follows Artemis 3?
I do not know.
Okay.
The Artemis 4, so the current plan, we need to put a gateway, which will be an outpost, and so I'm not sure what the current plan is, to be honest.
Okay.
The original one was to put gateway in place, and then they would take Orion across, dock at gateway, and then take a lander from gateway down to the lunar surface, and then they would go back and forth to gateway. Orion would go back and forth from Earth to gateway and do it that way. So, but I don't know if I haven't seen any current plans, so I don't know if that's still the plan, or what the the current configuration of the lunar lander is. So
okay. So we have a question in chat. Okay, this comes from Matt and Owen. Says, thanks for the great presentation, Leonard. What resources do you use to keep up to date with the information and or prep a presentation like this?
So a lot of it I get, if you look at the missions, a lot of them will have a mission blog. So like a lot of the Mars information, I got that because that's coming straight from the team. And so you just, I would say, Google Mars Perseverance blog, and there's a pretty much update, pretty recent update on that type of stuff. There now we do have, the solar system ambassadors are sending us out frequently, trainings, and like they did one for Europa Clipper. There's one coming up for Artemis. So some of that I get from that. But your real-time stuff is really, they're pretty good about publishing stuff in the blog, the X, Twitter feed is pretty good. A lot of that they keep the news pretty current. So if you go Google it, you can get pretty recent information.
Hey, I have an obvious follow-on question, which is, how does a person become a NASA Solar System ambassador?
So I haven't seen an announcement. They usually issue what they call an announcement of opportunity, usually in September. I have not, they don't do it every year, so I haven't seen one coming out this year.
Okay.
But yeah, they open that up for several weeks, and you go through an application process, and yeah, it's open. Like I say, most years I haven't, like I said, I haven't seen one this year. But yeah,
Okay.
generally September, October, look for an announcement of opportunity, and go for it.
So I have another follow-on question, which is, to the best of your knowledge, how old is the youngest solar system ambassador?
I do not know the answer to that.
Okay. I was just wondering if somebody, along the age of like Matt Pateau might be eligible for that sort of position, if somebody like Matt was interested in it.
Okay. Yeah, let me check on that.
Okay. Folks, who has the next question?
I just had an anecdote to share, Leonard and everyone else here. Years ago, I think it was 2009 or 2010, NASA had actually visited my employer, and I was actually in charge of a downhole tool, which actually goes downhole and extracts a core sample. And I did not know at that time. I knew that they were trying to send a rover to Mars to do a drill, but I did not know the level of detail that I know now, of course. And now when seeing the pictures and them drilling holes, it gives me goosebumps to think that we were at the very beginning of it all. They had come to see.
Wow.
So they made me drill a hole in a marble block, and they wanted to see and they wanted to understand the mechanics of what we were doing. And I see the technology used on Earth now has made it into Mars. So I just thought it was always cool.
Yeah, so that's probably what both the rovers, because they used a lot of the same technology on Perseverance as on Curiosity so Curiosity launched 2011, landed 2012. So, but the rock drills and all that, I think they're pretty much identical. Even Perseverance's power supply is actually the twin to the one for Curiosity. So yeah, that's very cool.
And yet another follow-on question. So again, pardon the ignorance, but how long do we expect the Perseverance mission to run to?
So they do. So both of them, Curiosity and Perseverance, they had a 5-year primary mission, and then after that, when it starts coming up, the team will do. They have to do a proposal and a request for a mission extension, and then that goes to NASA, and then NASA goes through all of its, all of its approval cycles and that, and then if it gets approved, then the mission keeps going. So I think Perseverance is landed 2022. So at some point, with the good science, the team will do an extension. So after that primary mission, then everything else is an extension. So that's like we talked about Juno. It had its primary mission, and they did. Same with New Horizons. New Horizons' primary mission went to I think 2015. Okay, but basically its primary mission was to fly by Pluto, and and then so now everything else is an extension. So yeah, just as long as they're getting good science out of it and they keep doing requests and they get approved. So
okay, very good, folks. Who has the next great question? Well, Leonard, thank you so much. This has been incredibly informative. Really appreciate your taking the time to put the presentation together and to present it to us. And we're looking forward to having many more in the future.
Yay. Well, sorry about the rough start, but
that's okay. Like I said, the result is what matters, and the result turned out great.